Okay, today we're going to talk about solving trig equations. Solving equations that have trig functions in them is fairly easy. It involves a couple more steps, but the main thing to realize is we want to treat the trig function like a variable. So we will solve for the variable first. That looks really bad. Okay, so if we look at this first equation, and we look and we see that we have a cosine of x in here. Okay, this cosine of x is what we need to solve for initially. So to get cosine of x by itself, remember we're treating it like a variable, we're going to first subtract 6 from both sides. And that will leave us with 3 equals 5 times the cosine of x. Now we still need to get cosine of x by itself, so we'll divide both sides by 5, and we get cosine of x equals 3/5. Now we still need to solve for x now that we've got cosine by itself, but we can use our inverse functions at this point to do that. So x is going to equal the inverse cosine of 3/5. And when we calculate that, we find the inverse cosine of 3/5 is equal to 53.13 degrees. Now remember, this is just a reference angle. Okay, this just tells us that we need to figure out now what quadrants this belongs to. Remember, all students take calculus. Everything is positive in a first quadrant, only sine is positive in the second, tangent is positive in the third, and cosine is positive in the fourth. 3/5 though is positive, and we're dealing with cosine. So cosine is going to be positive in the first quadrant and the fourth quadrant. So what we're really dealing with is a reference angle of 53 in the first quadrant as well as the fourth quadrant. Okay. Now in the first quadrant, x really can be 53.13 degrees because the reference angles in the first quadrant match the actual angles. But in the fourth quadrant, we're going to need to take 360 minus 53.13, and we get 306.87 degrees. Okay? And if we want to check our work to make sure this is actually the case, we can take the cosine of 306, right, 0.86, multiply it by 5, add 6, and we will in fact get 9. Okay? We can do the same thing with 53.13. We can take the cosine of it, multiply by 5, add 6, and still get 9. Okay? So make sure that you run these answers through your original equation to check them out before you just believe them, so you can make sure that you actually get the answers in the correct quadrant. So here's a recap of how this works. When the trig function is isolated, we get to a decision point. Each trig function has two quadrants where it's either positive or negative. Okay? So, another important thing to do when solving trig equations is to look for factors. Okay? And we'll see an example of that on the next page. We have two more example problems. This first example problem looks a lot like the other example problem, only it deals with sine. So let's run through this one. Remember, we need to get our sine x by itself. And so we'll subtract 3 and we get 5 times the sine of x equals 4. We'll divide by 5, and we get sine of x equals positive 4/5. So x will equal the inverse sine of positive 4/5. Okay, now we're at our decision point, remembering all students take calculus, and we have a positive 4/5, and we're dealing with sine. So we're looking for where sine is positive, and that's going to be in quadrants 1 and 2. So this reference angle that we get is going to be something that's in quadrants 1 and 2. So 4/5, and the inverse sine of that is going to be 53.13 degrees, same as the other one. So 53.13 degrees for this reference angle, as well as 53.13 degrees for this reference angle. Okay. Now, because the second quadrant reference angle, we can't count on that to just be 53.13. We're actually measuring from clear over to here. So the easiest way to calculate that is to take 180 minus 53.13 to find our angle that we're dealing with. And that is going to be 126.87 degrees. And we can check our work by saying 5 times the sine of either 53.13 degrees or 126.87 degrees plus 3 should equal 7. Okay? If you end up getting something that doesn't equal 7, you might have to look for your reference angles in the other two quadrants. Now let's look at this one. Okay, here we have a sine squared and a sine and a 4. And remember I said to try to treat these as variables. So if we were just dealing with sine being a variable, we see a squared, we think quadratic. So we can bring this 4 over by subtracting, and we end up with 10 times the sine squared of x minus 3 times the sine of x minus 4 equals 0. At this point, we can decide to factor. Okay, we're going to use our AC method, and A is 10 and C is 4. So we're dealing with an AC value of 40. So we're looking for factors of 40 that subtract to give me 3, and that's going to be 5 times 8. So I'm going to break this up into this middle term up after I rewrite the first term. And we will have negative 8 sine x and a positive 5 sine x minus 4 equals 0. And now we do factor by grouping. And I'm going to group these like so. Okay, just because it's going to work better for my factors. Okay, so for the red ones, what I have in common is a 5 sine of x, right? When I factor that out, I'm left with 2 sine x plus 1. For my blue terms, what I have in common there is a minus 4. When I factor that out, I'm left with 2 sine x plus 1 again equals 0. Now I have 2 terms, and I have to figure out what each of these has in common. Well, they clearly have a 2 sine x plus 1 in common. When I divide that out of each term, I'm left with 5 sine, oh, that looks bad, 5 sine x minus 4 equals 0. Okay, so what we can do now is we can take 2 sine x plus 1 and set it equal to 0, and we can take 5 sine x minus 4 and set it equal to 0. And then we have to isolate sine for each of these. So we'll subtract 1 and we get 2 sine x equals negative 1, and sine x will equal negative 1/2. So x will equal the inverse sine of negative 1/2. Here we add 4 to both sides and we get 5 sine x equals 4. So sine x will equal 4/5, and x will equal the inverse sine of positive 4/5. So for this first, we're dealing with negatives, and remember, all students take calculus. We want to find out where sine is negative. Well, we know sine's positive in quadrants 1 and 2, so our angles are going to be in quadrants 3 and 4 for this. For the other one, we want where sine is positive. Okay, so these two reference angles will exist in quadrants 1 and 2. So, now let's find out what our angles are. So x is going to equal the inverse sine of negative 1/2. And we get negative 30 degrees, okay, which tells us, yes, we are definitely in quadrant 4, okay? And we also know that other one's going to have to be over here in quadrant 3. So negative 30 degrees is actually 330 degrees in quadrant 4. And in quadrant 1 or quadrant 3, it's going to be 210 degrees because 180 plus 30 is 210. So these are the two solutions for that half. And here, the inverse sine of 4/5 is going to be 53.13 degrees again. Okay, and so we know we're dealing with that in the first quadrant, so that answer is good. And in the second quadrant, we're also dealing with this. So if we subtract that from 180, we get 126.87 degrees. So we actually have 4 solutions to this equation. Okay, and so you'll need to check out all 4 to make sure they actually work. Long problem, I know, but it kind of uses all the skills that we've been using here in the last few months to solve different equations.